Now we would be learning about a science topic called chemical reaction. I'm sure you have learned about different chemicals in your previous classes and have some basic information about it. But today we will be learning more. You must be thinking it's a very difficult topic, but chemical reactions are everywhere, even in your home environment. What happens to the milk if you keep it overnight? What happens to the food if you keep it for a long time? How does it get spoiled? What happens to the atta if you keep it for a long time? What is happening when you remove the nail polish? All this are examples of chemical change. You can see it all around you in your home. I want to give you two more examples. That's metal, iron rod. And what has happened to it? It's become rusted with rain and wind and moisture. The color has changed. That is a chemical reaction. If you keep the iron rod in contact with air and moisture, it changes. It rusts. On the left hand side you can see iron, and on the right hand side you see rusted iron. Another example is coal. What happens when you burn coal? That's also a chemical reaction. In that reaction, a new gas called carbon dioxide comes out. Now you have seen the two examples, but I think I'll show you three more activities so that you know what happens in a chemical reaction. That's activity 1. As all of you can see, that's a magnesium ribbon. It's one kind of metal. And that's the fire. When you start burning magnesium ribbon, it changes into ash. So what's really happening? It's changing. When you burn magnesium, the structure of magnesium changes from solid form to ash. Now see activity 2. That's lead nitrate. It's one kind of chemical. Another chemical, potassium iodide. When you add potassium iodide to lead nitrate, it changes into lead iodide. When you mix those two chemicals, the color change happens. And that's a chemical reaction. Now see activity 3. Those are zinc granules. When you add sulfuric acid to zinc granule, and please be careful when you add this acid, it can damage your skin. After you add sulfuric acid to zinc, it changes into zinc chloride plus a chemical reaction occurs and hydrogen gas is emitted. So what really happens in a chemical reaction? There is a change in heat, color, the physical structure. All this is part of chemical reaction. I hope the examples are clear to you. Now we'll learn about chemical equation, how to write about chemical reaction, what is the notation that we follow. I've already explained to you about how when a coal burns, carbon dioxide is released. This is the same example. CO2. How do we get CO2? What is there inside CO2? It has one carbon plus two oxygen. When you combine those two, we get carbon dioxide. So carbon and oxygen combine to give you carbon dioxide. Carbon and oxygen here are the reactants, and carbon dioxide is the product. The reactants are reacting to give you the products. The reactants are put on the left hand side and the products are put on the right hand side. I hope you understand well. Now different chemical equations have to be balanced. That means the reactants and the products have to be equal. I'll give an example. That's zinc. That's H2SO4 or sulfuric acid. On the right hand side we have zinc sulfate. So you can see in the left hand side there was one atom of zinc and it remains the same. Similarly, hydrogen, we had two on the left hand side, has to be balanced on the right hand side. So both sides have to be balanced. You can see this picture which explains it. How many molecules on the left hand side and how many on the right hand side. If you want more clarity, you can look here. So how many zinc we had? One. It has to be one on the right hand side as well. So like that, we balance an equation. I have already told you about the reactant and the product being balanced in a chemical equation. So we'll try to do that in this example. Let's see if it's already balanced or not. Fe, which is iron. Left hand side we have 1, on right hand side we have 3. H2O on left hand side. So we have only 1 on the left hand side and right hand side we have 4. Hydrogen, I can see both are 2. But somehow this equation is not balanced. Now how can we balance this? So first we look at the equation and at the different chemicals, which one has the highest number of atoms. So we see here O4. On left hand side it's only 1. So we'll first try to balance this. Now how do we do that? I'm going to explain that. So we have O4 here. How do I change the left hand side O into 4? So I'll just add 4 to H2O. If you write it like this, that would be incorrect. And even this in the bracket would be incorrect. The right way of writing is 4H2O. So 4H2O would balance the oxygen molecule. Now after oxygen is balanced, what is the second one? We have iron, which has 3 atoms on the right hand side, and on the left hand side we just have 1. So now we would balance iron, which is Fe. So oxygen was already balanced, O4, both RHS and LHS are equal. Now second, we would go for Fe or iron. So we'll add 3 to left hand side, and iron is balanced now. Both sides, 3 atoms. Now let's see if hydrogen is balanced. On the left hand side we have 4H2, and on the right hand side we just have one molecule of H2. Now we have to balance this, so we add a 4 to right hand side as well. Now after doing all this, let's check if the equation is balanced. Left hand side and right hand side, are they equal or not? This is how we balance an equation. Now in a chemical equation, there are certain terms, certain notations that we use. So here you see S in bracket. What does this S stand for? So iron is a metal which is a hard, solid metal. So S stands for solid. Now in this H2O, you see G in the bracket. That stands for gas. So hydrogen and oxygen both are gases, as you know. So G stands for gas. This arrow in the chemical equation shows the conversion of reactants to products. And this arrow, which is pointing upwards, shows when two chemicals react, a gas is emitted. There could be other notations used in chemical equations showing solid, liquid, gas, different things which you would be learning later. Chemical reactions are of different types. I'm going to explain one by one. First, we would learn about combination reaction. When two different chemicals combine and form one product. Let's see an example. I've already told you about burning of coal. The same example. So you see coal, which is actually carbon, a solid, combines with oxygen, which is a gas. That is, when we burn coal, it combines with oxygen and forms carbon dioxide, which is again a gas. So carbon and oxygen combine to make carbon dioxide. We'll see one more example. Formation of water. So we have two molecules of hydrogen combining with one molecule of oxygen to make water. So the water that you drink actually comes from hydrogen and oxygen. So two gases combine to form the liquid, which is water. Again, you can see in the picture, hydrogen and oxygen combine to make water. Two gases combine to form water. That's the competition reaction. Next, we would learn about exothermic reaction. Exo means out or outwards. Thermic means related with heat. So when two chemicals react, heat is released. Along with the product. Now we'll see an example. Burning of natural gas. You must have seen CH4 or methane gas when it is burnt in presence of oxygen. So that is two chemicals reacting. We get heat, and that's why the exothermic reaction. Similarly, in the coal example, when we're burning coal in presence of oxygen, if you feel it, you would see it's hot. Another example, the process of respiration or breathing. What happens in it? We take in oxygen, which helps our body to break down the food into small components. That small component is basically glucose. Same thing that you use while you're running to get energy. Yes, glucose. So glucose gives you energy to do work. We take in oxygen, it combines with the food, and it also gives us energy to do work. It doesn't exactly heat us up, but gives us energy to do work, running around, watching, studying, moving around, exercising. All that energy comes from food, which is broken down into glucose in presence of oxygen to give us energy to walk. So you can see how important oxygen is for us. If we don't have oxygen, we would all die. Oxygen allows us to live and work. Now I want to show you something very interesting. You all know about glucose, the thing that you mix in water. But do you know its chemical name? It's C6H12O6. What in bracket you see AQ. We've already learned about solid, liquid, and gas. Similarly, AQ means aqueous solution. That means it has water in it. So when glucose combines with oxygen, carbon dioxide is released. So as you can see, when you breathe, you take in oxygen and you give out carbon dioxide. So 6 molecules of oxygen we take in and 6 molecules of carbon dioxide. So we all should try to learn about this chemical processes. It's an important chemical reaction. Next, we would learn about decomposition reaction. What does it mean? That we have one reactant and inside, after applying heat, it breaks down into 2 or more products. So it could be metal or gas or liquid, and it breaks down into 2 or more products. I'll show you an example. As you can see, that's ferrous sulfate. Ferrous is basically iron, so iron sulfate. So you take that in a test tube and you apply heat. and you would notice a color change from green to golden. Also, there is emission of certain gases. So the chemical reaction which is happening here, when we heat ferrous sulfate, we get ferric oxide. Also, a gas called sulfur dioxide, and third gas called sulfur trioxide, SO2 and SO3. So SO2 is sulfur dioxide and SO3 is sulfur trioxide. So you can see the one reactant which was hard after application of heat breaks down into three components. So one solid and two gas. So in a decomposition reaction, one reactant breaks down into two or more products. I'll give you one more example. You all must be knowing about limestone. It's same as the chalk that we use in the house. It's one of the minerals that we get from inside the earth. If you take this limestone and you heat, you get two products. One is calcium oxide called lime that you actually use in painting. And the second one is carbon dioxide. So after you heat limestone, you would also notice a color change and formation of two products, calcium oxide which is used in painting in the house, popularly known as chuna. I hope it's clear. Next, we would see what endothermic reaction is. Do you remember earlier we have discussed exothermic reactions, where heat was released? So endothermic reaction is just the opposite. Endo means inside. So we have to provide heat for the reaction to occur. So here you see any reactant or chemical. When we apply heat to it, it could be sunlight, it could be heat from coal or burning. It breaks down into two or more products. I'll give you one example. Silver chloride. So we take the china dish and we put some silver chloride on it and we put it out in the sun for some time. We'll observe a chemical reaction. The color would change. The chemical equation is this. So silver chloride is AgCl. When you provide sunlight, it would break down into silver and chlorine gas is emitted. Also, there is a color change. So before it was only silver chloride. After you provide sunlight, it breaks into silver and chlorine gas. Now we would see displacement reaction. In displacement reaction, the element from one reactant replaces the element in another reactant. Now if you see here, that's reactant A, and that is reactant B. When they react, you see those two elements? It gets displaced because of the other reactant. I'll show you an example. So in an experiment, we take iron with copper sulfate. So you see the blue color, that's copper sulfate solution. And that is the iron nail that you have dipped into the copper sulfate solution, and you wait for a certain time. You would notice that the blue color of the copper sulfate solution becomes transparent. Because of the displacement reaction. And the iron nail also changes color because of the displacement reaction. Now we'll see the equation for this reaction, that is iron, or Fe. That's the copper sulfate solution. When you put iron nail in the copper sulfate solution, the AQ here stands for that the solution has water in it. You would get, so the sulfate, which was earlier with copper, combines with iron and it forms iron sulfate. So displacement reaction occurs. Now we'll see the double displacement reaction. So before it was only one element being replaced. Now we would have both the elements being displaced. That is the double displacement reaction. So element from the reactant A goes to reactant B and vice versa. Let me show you one example. So in this experiment, we have sodium sulfate and barium chloride. We take these two solutions and we mix. So what happens when we mix sodium sulfate and barium chloride? So earlier we had the sodium with sulfate and barium with the chloride. Both of these elements get exchanged. We have sodium chloride and we have barium sulfate. So this is the final thing that we get, where the sodium chloride, which is same as salt, remains in the solution, whereas the barium sulfate becomes insoluble in the solution, and you can see it as the precipitate, and you can remove it. Now we'll see how we can write the same in form of a chemical equation, this double displacement reaction. Na2SO4, that is sodium sulfate, BaCl2, that is barium chloride. Those are the two reactants. What really happens is we get barium sulfate after the displacement and sodium chloride. So we have sodium sulfate and barium chloride reacting to form barium sulfate and sodium chloride. So like this, there are many different kinds of chemical reaction. Another type of chemical reaction is precipitation reaction. What is the meaning of precipitation? Something which is left after the reaction is over, a precipitate. I've already shown you one example of sodium sulfate and barium chloride. When this reaction occurs, when we mix these two solutions, we get the precipitate of barium sulfate, which is insoluble in the solution. That is what is precipitation. Formation of an insoluble salt. So the same displacement reaction is happening, but in the end, what we get is a precipitate which is not soluble. Next, we can see the oxidation reactions. So oxygen is an important gas. It leads to many different chemical reactions. So you know copper, right? It's a kind of metal. When you heat copper, in a china dish, when you heat it for some time, the color of copper changes into black. Originally, the copper color is something orange and reddish. It changes into black because of the formation of copper oxide. So this is an example of oxidation reaction. So copper plus oxygen gives you copper oxide. That's the chemical reaction. So 2Cu, which is copper, plus oxygen O2 gives you 2CuO, copper oxide. And the color has changed to black now. The opposite of oxidation reaction is reduction reactions. Before we did oxidation, this is exactly the opposite of oxidation reaction. So here we add hydrogen, or we remove oxygen. It's the same process. So hydrogen is added and oxygen is removed. Let's see an example. So before you saw formation of black copper oxide when we heated copper in presence of oxygen. Now if we add hydrogen to this, the color would change to the original color of the copper. The oxygen would be removed. So in oxidation reaction, oxygen is added, and in reduction reaction, oxygen is removed. So that's why these two are opposite reactions. So we would write this equation as that CuO, copper oxide, and you add hydrogen molecule to that. So the oxygen molecule is removed. And in this process, water is released. And the color goes back to the original color of metal copper. That's the reduction reaction. Now we would see redox reaction. We've already learned about oxidation reaction and reduction reaction in which hydrogen was added. So these two reactions I hope you remember. Now if both happen at the same time, the oxidation as well as reduction, both are happening at the same time, we call it a redox reaction. For an example, look at zinc oxide. So ZNO, that is zinc oxide, if you add carbon to that, that is C, they both react. And what happens next? The zinc is reduced, that is, the oxygen is removed, plus the carbon, which was only C, now get oxidized. So the oxygen is removed from zinc and added to the carbon. As you can see, there are so many different kinds of reaction. Maybe you can learn more, discuss, and get more experience and understand more about the topic. I have already explained about oxidation reaction, how chemical changes happen when you add oxygen. There are many different effects of oxidation reaction. For an example, corrosion. What happens to the metal? Why does it rust and get corroded? It's because of oxidation reaction. If there is moisture and wind, presence of oxygen, the color of the metal changes and it becomes corroded. Similarly for gold rings and then silver, if you keep them for a long time, they turn black and difficult to clean. So in this way, oxygen forms a layer on different metals and leads to color change. Oxygen is really powerful and has many effects. So you must have seen old cars and buildings falling down and bridges falling down. What exactly is the reason behind that? That is corrosion of metals because of presence of oxygen, and metal lose their strength after corrosion. So it is important to make a film to prevent contact with oxygen and moisture. Otherwise, in a few years, the entire building can collapse. Similarly, if you see these ships, because of the salt water and wind and moisture, the strongest of the ship can sink. So you have seen how oxidation affects metal. It also affects our food. You know, different kinds of food that we eat in home. So for an example, potato fries and fruits, we keep it for some time and we can see the color change and the taste and the smell changes. The reason for that too is oxidation reaction. The food reacts with oxygen. So for an example, potato, if you keep for a long time, especially if it has salt in it, after some time, it can become bad. So if you want to protect it for a longer time, you need to prevent contact with oxygen. For an example, jams and other things that you want to protect, you have to keep in tightly sealed cans so that it can stay for a longer time without getting spoiled due to oxygen. And hence, oxidation reaction can have several negative impacts.